Introduction to Plasticity Mechanical Properties. Plasticity is a fundamental mechanical property that describes the ability of materials, especially metals, to undergo permanent deformation without fracturing. Understanding plasticity is crucial for engineering design as it governs the behavior of materials under various loading conditions. Definition of plasticity. Plasticity refers to the irreversible or permanent changes in the shape or size of materials when subjected to external forces. This is in contrast to elastic deformation, where the material returns to its original shape and size when the forces are removed. Stress-strain relationship in plastic deformation. Elastic region. In this region, the material deforms reversibly and the stress-strain relationship is linear following Hooke's law. Plastic region. Beyond the yield point, the material exhibits plastic deformation where the stress-strain relationship became non-linear and the deformation is permanent. Fracture. Eventually, the materials will reach its ultimate strength and fracture, resulting in the complete loss of load-bearing capacity. Factor affecting plastic deformation. Temperature. Increasing temperature generally makes materials more ductile and easier to deform plastically. Stress strain rate. Higher strain rates can lead to increased strength and reduced ductility in some materials. Microstructure. The arrangement and orientation of grains and other microstructure features can significantly influence plastic behavior. Alloying element. Adding alloying elements can modify the plastic properties of metals by affecting their crystal structure and defect characteristics. Yield criteria and yield surfaces. Von Mises criterion, widely used to predict the onset of plastic yielding in ductile materials. Tresca criterion predicts yielding based on the maximum shear stress in material. Yield surfaces. Graphical representations of yield criteria in multi-dimensional stress space. Hardening mechanism in metals. Work hardening. Increasing the density of dislocations in the crystal structure. Solid solution hardening. Introducing alloying element that distort the crystal lattice. Precipitation hardening, forming small dispersed particles that impede dislocation motion. Application of plasticity in engineering design. Metal forming, structural design, impact and crash analysis, failure analysis. These four categories the application of plasticity in engineering design. Conclusion and future trends. Plasticity is a fundamental and complex topics in materials science and engineering as materials continue to evolve, the understanding and modeling of plastic behavior will remain a critical area of research, enabling the development of more innovative and reliable engineering solutions.